All right, let's get into it. We're about to go on a trip to the absolute edge of what we know, mixing real, hard science with those huge cosmic questions that make for the best science fiction. I mean, we're talking about the biggest questions you can even think of. Stuff like,
How is this whole thing, the universe, gonna end? What's the final chapter for everything we see, everything we know? Is it all gonna go out with a bang? Or just fade away?
And what about time travel? I mean, is the past just gone for good? Or could we, just maybe, find a way to bend the rules of reality and actually go back?
And then there's the big one, the question that really keeps you up at night. In this unbelievably huge cosmos, are we it? Are we really the only ones out here?
Okay, so to get our heads around these massive ideas, we gotta start where it all began, right? If you want to know how the universe is going to end, you first have to understand how it was born and how it's lived its life. It's the whole story of, well, everything.
You know, you can almost think of the first few moments after the Big Bang as the universe writing its own DNA. I mean, in the very first fraction of a second, all the fundamental forces of nature were just one thing. Then bam, this insane hyper-fast expansion called inflation happened, stretching the universe out and making it incredibly smooth. Just 20 minutes in, you've got the first atoms being cooked up. And then, fast forward about 377,000 years, and things finally cool down enough for light to break free. That's the ancient glow we can actually still detect today. Every single one of these steps was absolutely crucial. They set the rules for the entire game.
So, what was the universe actually made of back then? It was surprisingly simple, really. Just two main ingredients, about 75% hydrogen, 25% helium, and a tiny pinch of a few other light elements. That's it. From that incredibly basic starter kit, every single star, every planet, every galaxy we see today was built.
okay, so if that's the beginning of the story, what's the end? Right now, there are basically three competing theories, and it's this epic cosmic tug of war between gravity trying to pull everything back together and this mysterious thing called dark energy that's pushing everything apart. The frontrunner, the most likely scenario, is called the Big Freeze. The universe just keeps expanding forever until it becomes this cold, dark, empty place. But if gravity somehow wins the fight, we could get the Big Crunch, everything collapsing back in on itself, maybe for another Big Bang. And then there's the most terrifying one, the Big Rip. That's where dark energy goes wild and literally tears everything apart, right down to the last atom. All right, let's pull back from the fate of the entire universe for a second and zoom in on some of its weirdest, most extreme inhabitants. We're talking about places where the laws of physics as we know them just seem to give up. Yep, you guessed it. We're talking about black holes.
So what is a black hole, really? The simplest way to think about it is a spot in space where gravity has gone completely off the charts. It's so strong that it creates a one-way door in the universe. Once you pass that point of no return, the event horizon, that's it. Game over. There is absolutely no coming back. Not for a spaceship, not for a star, not even for light itself. They're the ultimate prisons of the cosmos.
Now here's where things get even weirder. The same math that predicts black holes also allows for their exact opposite, a white hole. Instead of sucking everything in, a white hole would be constantly spitting stuff out, and you could never get inside one. But here's the puzzle. We see black holes everywhere. They form from dying stars. But white holes? We've never seen one, and we have no idea how one would even form. In that absence, that tells us something really deep about the universe. It seems like time only flows in one direction. It's like a cosmic Hotel California. You can check into a black hole anytime you like, but you can never leave from a white hole. The arrow of time only points forward.
And this is where science fiction can be so cool, right? Take the movie Interstellar. The filmmakers actually worked with a top physicist, Kip Thorne, to get the science right. So when you see that shimmering wormhole or that incredible black hole gargantua, that's not just some artist's guess. Those visuals were generated using Einstein's actual equations of general relativity. So appearance-wise, they are shockingly accurate. But, and this is a big but, they had to cheat a little for the story. The crazy time dilation, 1 hour on the planet equals 7 years back home, that's theoretically possible, just probably not to that extreme. But surviving on a planet orbiting that close to a black hole? No way. The radiation and tidal forces would shred you in an instant. It's a perfect example of that line between what's real and what makes a good movie.
Okay, so all this talk about warping space-time around black holes naturally leads to an even crazier idea. If gravity can bend space, could it also bend time?
Let's really go down the rabbit hole and talk about the physics and the mind-bending paradoxes of time travel.
So, to even have this conversation, you gotta be willing to stretch your brain a little. A lot, actually. See, a lot of modern physics, like string theory, just doesn't work with the 3 dimensions of space and 1 of time that we know. M-theory, one of the leading ideas, needs a whopping 11 dimensions for the math to pan out. So, where are they? The best guess is that they're curled up, incredibly tiny, way smaller than an atom, completely hidden from us. But the crazy part is, the way they're shaped and how they vibrate might be what determines all the fundamental laws of physics in our universe.
And this leads us right to the biggest headache with time travel, the paradoxes. Specifically, the most famous one of all, the grandfather paradox. It goes like this. What if you built a time machine, went back in time, and stopped your grandfather from ever meeting your grandmother? Well, then your parents would never be born, which means you would never be born. But if you were never born, who went back in time to stop them in the first place? See? It's a complete, brain-breaking logical knot.
So how do you get out of that mess? Well, physicists have come up with a couple of clever workarounds. The first one is called the Novikov Self-Consistency Principle. It basically says the universe won't let you create a paradox. The timeline is fixed. Anything you try to do to change the past was, in a way, always part of the past. It means what's happened has happened, and free will is kind of an illusion. The other, maybe more fun idea, is the many worlds theory. In this version, when you change the past, you don't actually change your past. You just create a brand new, branching timeline, a whole new parallel universe. You didn't erase your own history, you just hopped over to a different one.
And that first idea, the Novikov principle, that's the engine that drives the whole plot of the movie Tenet. The film's big gimmick is time inversion, this idea that you can reverse an object's entropy, its natural march towards chaos, and make it move backwards through time. Now the how is pure sci-fi, but the rule of their universe is pure Novikov. What's happened, happened. They avoid all the classic paradoxes because the timeline is a closed, unchangeable loop. It's a really smart way to build a story around a complex physics concept.
Okay, so we've gone from the very birth of the universe all the way to its possible end, and even flirted with the limits of reality and time itself. Which brings us to our last big question. And this one feels a little more personal. With all this mind-boggling scale and complexity, are we the only ones here to wonder about it all?
This is the core of what's known as the Fermi Paradox, and it's a real head-scratcher. When you just run the numbers, billions and billions of stars in our galaxy, most with planets, many of them in the right spot for life, it feels like the universe should be absolutely buzzing with civilizations. But when we actually point our telescopes out there and listen, we get nothing. Just silence. The probability says we should have neighbors, but the evidence says we're completely alone. So what gives?
A great way to think about this problem is the Drake equation. And you shouldn't think of it as a math problem you can just solve for x. It's more like a recipe or a framework for our own ignorance. It takes the giant question, are we alone, and breaks it down into a list of smaller questions we can actually try to answer. You know, how many stars are there? How many have planets? How many of those could support life? And so on. Each part is a huge mystery, which is why the final answer could be millions of alien civilizations or just one. Us.
You know, for the longest time, we were kind of stuck looking for Earth 2.0. We thought life needed these perfect, gentle conditions. But then we discovered extremophiles right here on our own planet, and that completely changed the game. These are tiny life forms that don't just survive, they thrive in places we thought were totally impossible. Boiling deep-sea vents, the middle of frozen wastelands, even in radioactive zones. It proves life is way, way tougher than we gave it credit for. And it means we should be looking in all sorts of wild places, like under the ice of Jupiter's moon Europa, or deep beneath the surface of Mars.
And this has led to a really clever new search strategy. It's based on a simple question. What if we've been listening for the wrong kind of signal? I mean, think about it. The most powerful, most obvious signals we send out into space aren't some hello universe message. They're tight, focused beams we use to talk to our own rovers on Mars or probes out past Pluto. So the new idea is to flip that around. Let's stop waiting for a message meant for us and instead try to eavesdrop on aliens talking to their own stuff. If we listen at just the right time when their planets are aligned, we might just overhear their version of mission control.
So, when you step back, we've gone on quite a journey, from the pretty solid science of the Big Bang all the way out to the super speculative fringes of physics, things like extra dimensions and time travel. It really shows you that exploring the universe isn't just one thing. It's this incredible blend of hard data, mind-bending theory, and a healthy dose of imagination. The most amazing discoveries are almost always waiting for us right at the edge of what we think we know.
And that brings us right back to where we started.
with a huge, unanswered question. That great silence we hear from the cosmos, is that the answer? Is it telling us that we truly are one of a kind, all alone in this immense universe? Or is that silence just a reflection of us? A sign that we're still just cosmic toddlers who haven't figured out how or where to listen properly yet?